Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to add and subtract rational expressions which have different denominators. I'm going to assume that you know how to add and subtract polynomials, that you know how to add and subtract rational expressions which have the same denominator, that you know how to find the least common multiple of two polynomials, and that you know how to simplify rational expressions. Okay, what are the steps for adding and subtracting rational expressions which have a different denominator? Well, we need to find a common denominator. So we start by factoring the denominator of each rational expression. And we find a least common denominator. The least common denominator will be the least common multiple of each denominator that we need to add. Once you've found the least common denominator, you need to rewrite each rational expression as an equivalent expression which has the least common denominator. So to do this, you figure out which factors are missing from each of the original denominators that you would need to get the least common denominator. You multiply the numerator and denominator of each term by those missing factors. Once you have each rational expression has the same denominator, then you add or subtract them and simplify if necessary. Let's look at an example. We want to add these two rational expressions. Now we said our step one was to factor the denominators, but the denominators here are monomials, so there's nothing to do there. So the next step is to find the least common denominator, which is the least common multiple of each denominator. So we have 12x to the fourth. We can write 12 as 2 squared times 3, x to the fourth y, 8 is 2 cubed, x squared y cubed, and the least common multiple is just all of the unique factors to their greatest power. So we have a 2 cubed is the greatest power of 2. We also have a 3. We have x to the fourth is the greatest power of x, and y cubed is the greatest power of y. So the least common multiple would be, it would be 8 times 3, so that's 24, x to the fourth, y cubed. Now I need to multiply. So you notice that we're missing factors here that are here. So we need to multiply the numerator and denominator of each one of these rational expressions by the missing factors. So for instance, for the 7 over 12x to the fourth y, I'm missing a factor of 2, right? 12 times 2 will give me 24, and I'm missing a factor of y squared. So I'm going to multiply the numerator and denominator by 2y squared, right? I need to multiply by 1. I cannot multiply by anything else than 1, as that would change the expression. Now in the other one, what am I missing from the denominator to get the least common denominator? I need a factor of 3 so that I have 8 times 3 by 24, and I'm missing a factor of x squared, right? If I want to multiply x squared by x squared to get x to the fourth. So we multiply the numerator and denominator by 3x squared. Okay, and now we can write each term as an equivalent rational expression. So in the numerator for the first one, we have 14y squared over 24x to the fourth y cubed. And the second rational expression will be 15x squared over 24x to the fourth y cubed. And now we have two rational expressions. Each one is equivalent to one in the original problem, but they have the same denominator. And so we add these together, we get 14y squared plus 15x squared over 24x to the fourth y cubed. And we're done. The numerator cannot be factored, and so there's nothing else to do here. This is simplified. Example 2. Okay, we need to subtract these two rational expressions, but they have different denominators, so we need to find a common denominator. We do that by first factoring each one. So the first rational expression, the denominator is x squared minus x minus 2. That will factor into x minus 2 times x plus 1. For the second rational expression, its denominator is x squared minus 1, a difference of squares, so it will factor into x plus 1 times x minus 1. And the least common denominator is just the product of the unique prime factors we have. So We have an x minus 2, we have an x plus 1, and another x minus 1 here. So the least common denominator will be x minus 2 times x plus 1 times x minus 1. All right, the next step is to write each rational expression as an equivalent rational expression which has the least common denominator. So the first one, we have we have an x minus 2 times x plus 1. So from the LCD, we're missing the x minus 1 factor. So we multiply the denominator by x minus 1, but we also multiply the numerator by x minus 1 so that we did not change the rational expression. We only multiplied by 1, right? X minus 1 over x minus 1. For the second term, we have 6 over x minus 1 times x plus 1. From the denominator here, we are missing the factor of x minus 2. So we multiply in the denominator by x minus 2 and in the numerator as well. Now we need to combine these into a single rational expression with a single denominator. So we have, from the first one, we want to distribute that 9. So we'll have 9x minus 9. And now let's distribute that negative sign in here. So we have, when we distribute the 6 to the x minus 2, include the negative sign. So we have negative 6 times x will be negative 6x. And negative 6 times negative 2 would give me positive 12. And that will be all over our common denominator. Okay. So in the numerator, we have 9x minus 6x will give us 3x. We will have negative 9 plus 12 will give us positive 3. And then we have that over our common denominator, x minus 2 times x plus 1 times x minus 1. The last thing we need to do is simplify this. So from the numerator, we can factor out a 3. So we have 3 times x plus 1 over x plus 2 times, that's x minus 2, I should say. X minus 2 times x plus 1 times x minus 1. So we have that common factor in the numerator and denominator of x plus 1, so we will cancel it out. And it leaves us with our final answer of 3 over x minus 2 times x minus 1. Okay, here's our final example. We need to start by finding the least common denominator. So the first two denominators are factored. So that would be y plus 2 and y. The last term there, the denominator is y squared plus 2y. We can factor out a y. And so it leaves us with y times y plus 2. So if we look at all of the unique factors, we have a y plus 2 and a y. We have those factors here as well, but we don't need to list them twice. So the least common denominator is just y times y plus 2. So now we need to rewrite each term as an equivalent rational expression by multiplying the numerator and denominator by the missing factors that are in the LCD. So for the first one, we have 3y over y plus 2. The missing factor from the LCD is y. So we multiply the numerator and denominator by y. For the next term, we have 4 over y. The missing factor from the LCD is y plus 2. So we multiply the denominator and the numerator by y plus 2. And then for the final term, there are no missing factors, right? The denominator is already the LCD. Okay? And now we combine these over a single denominator. So we'll have 3y squared plus we distribute the 4 times y plus 2, so we get 4y plus 8. And then we're subtracting y plus 8. So we're going to have minus y minus 8, right? We distribute that negative sign to both terms. And that will be all over the LCD, which was y times y plus 2. We combine in the numerator, and we have 3y squared. We have 4y minus y is 3y. And we have 8 minus 8, which is 0. So we have 3y squared over 3y over y times y plus 2. Now, the last thing to do is simplify. We notice that we can factor out 3y from each term in the numerator. So we get 3y times, we'll have y plus 1 left over. And in the denominator, we still have y times y plus 2. We can cancel out that common factor of y, leaving us with our final answer, 3 times y plus 1 over y plus 2. And that's it for adding and subtracting rational expressions with different denominators. Now, my advice is to practice this a lot, but go slowly while you're doing these problems, at least at first. They're complicated problems with many steps, and one small mistake early on can affect your whole procedure. So practice, practice, practice. All right, until next time, have fun.